Here is question number 2. It's a knowledge-based question. At which point on the graph of f of x equals to minus 1 over 3x squared plus 2x minus 1 is the slope of the tangent 0? Prove that this point is a maximum for the given function. Okay, so now here we have to find the point where the tangent is 0. So we should use difference quotient method. So we'll find rate of change. As you remember, difference quotient is, this is my instantaneous rate of change symbol, is equals to f of x plus h minus f of x over h, right? Where h is very, very small as compared to 1. So think as if like h is 0.001, okay, 1000. Okay, now we'll plug in x plus h here and then write down our function. So the function becomes minus 1 over 3 x plus h whole square plus 2 times x plus h minus 1. So this is, I like to always put square brackets here. Fx plus h minus fx, which is this equation itself, minus 1 over 3 x squared plus 2x minus 1, correct? And everything is over h, correct? Now let's try to solve this. So we'll expand this here, and I'll write now 1 over h common, right? Let me write 1 over h here, and then put this kind of bracket. So I have minus 1 over 3, and yes, I should have put the square bracket also. So let me introduce that square bracket also, correct? 1 over 3, and I'll expand this. X square plus 2xh plus h square, bracket close, plus 2x plus 2h minus 1, right? So this is my first half. And then here I have minus 1 over 3 x square plus 2x minus 1, correct? I've already written h here outside the bracket, and I'll close this bracket, okay? Now, do you remember the first rule? All these three terms should cancel out at this stage, right? Rule number 1. Do they cancel out or not? Let's start. Minus 1 over 3x squared. Do we have minus 1 over 3x squared? Yes. If I multiply this with this, it becomes minus 1 over 3x squared. Minus this becomes 0, right? Plus 2x. Do we have plus 2x here? Yes, it is. Minus 1, minus 1. Do you see that? First thing. Second, out of the remaining terms, every term should have a h in it. Yes, h is there, h is there, h. Perfect. Now I can always factor out this h and right here and cancel these two h out. Do you see that? That's what I can do. So I will do that straight away because I've explained you, right? So I'm dividing by this h and I'm left with no h here. Okay, let me take this out first for you. You know, this step we are going to do in so many problems. So it's good to understand, and it's good to know the checkpoints so that we don't really land up into a mistake after doing so many calculations, right? Okay, so now, because we already got rid of this term, so we have minus 1 over 3 times 2xh, right? But I've already factored h out, so I'm left with times 2x. Is it okay? Plus, okay, minus, so let me minus 1 over 3 h, because 1h I've already factored out, and here I have plus 2 since h has been factored out. Do you understand? So if I multiply with this h, I get those terms. Perfect, right? Now since h over h cancels out, I am left with minus 2 over 3x And h is very, very small, so I'm neglecting this term and I'm left with just plus 2. Is it okay? So that is my instantaneous rate of change at any point x in the domain of the function f of x. Okay? Now, we want slope of the tangent to be 0. That means this instantaneous rate of change should be 0, right? So we have 0 equals to minus 2 over 3x plus 2. And then we can solve for it. We'll bring this term here. We get 2 over 3x equals to 2. And this implies x is how much? So we'll write here. I will solve and write it here now. So I'm taking from here to this place, okay? So we'll say x is equals to 2 times 3 over 2 over just 3. Correct? So at x equals to 3, we will have tangent as 0, right? Now this, as you see, this function is minus. So how will the graph be? For x square graph, because it is minus, it will open downwards, right? So the graph will be kind of like this. And that is our maximum. Do you see that? Okay. Now at x equals to 3, we have slope of tangent as 0. And now at least we have found the point. Now the second part of the question is, let me write this as a and this as b. Prove that this point is a maximum for the given function. So from the graph we know it is a maximum. So is it a maximum or not? How to prove it? So to prove it, what we can do is, let me show you here itself. If I find rate of change on the left side of this function, then it should be positive. And it is 0, we know here, right? And on the right side it should be negative. If the rate of change, instantaneous rate of change, changes from positive to negative, that means it's a maximum. So that is what we have to figure out, how to prove this part. Now I'll prove it like this. We have this formula here. We say instantaneous rate of change is this, right? This is our formula, correct? So we say, let me write this again here. So we say instantaneous rate of change is equals to minus 2 over 3x plus 2, correct? Now I will simplify it and write as, I will take 2 common. So if I take 2 common, I have got 1 here, and this is the minus term, so I'm keeping on this side, minus x over 3. Does it make sense? So that is my instantaneous rate of change. Now look here. Now we say that at x equals to 3, we have maximum, right? Any point on left side of this, maybe 2.9, let's say. And right side, we can take 3.1 as our test point, right? So if I write 2.9 here, then 2.9 divided by 3 will be less than 1, correct? Any point less than 3 for x, for 3 it is 1 and we know it is 0, right? But if I have a point less than 3, say 2.9, then I'm going to get a positive value, right? 1 minus something which is less than 1 will give me positive. So that means for rate of change at 2.9, I get a positive value. Is it okay? And how about rate of change at 3.1? You can always calculate though, but if I put 3.1, then 3.1 divided by 3 will be more than 1, and 1 minus more than 1 will give me a negative value. So I'll get a negative slope, right? So this slope here becomes negative, correct? So we found that the slope here is positive. Here of course it is 0, and then negative here. So if my instantaneous rate of change changes from positive to negative, then we have a maximum. That is the explanation for these 3 marks. Okay. Sometimes this question is asked under communication. So it is a very important question, and both the parts in this question are actually very critical. First one, to find a point on a given graph where the tangent is 0. Of course, that is a turning point, and we could expect a maximum or a minimum. Second part, how to prove that that point is maximum or a minimum, which we just now proved. So you have to check instantaneous rate of change on left side of the point and on the right side of the point. If it changes from positive to negative, it is maximum. If it changes from negative to positive, it will be minimum. Okay? In this case, it changes from positive to negative, and therefore it is a maximum. Correct? I hope you understand it. I wish you go through this video once again, try to get all the concepts and our checkpoints, and then move on to question number 3. Thank you.